Hello, welcome to the Math-159 Gould Chapter 3 Section 1 video. We're going to be talking about the properties of symmetric distributions. So remember, we're dealing here with numerical distributions, numerical variables. Oops. So we're dealing with a numerical variable. So the values are numbers. And you might recall that for the shape of a numeric distribution, that it can either be skewed or symmetric. And quickly talking about it, what you do is you look at the histogram, you find the mode usually. So I'm like drawing a histogram here. You want to find the mode, which should be in this case like right here. And then you measure the tails and compare them. So you can see the left tail is about this, the right tail is about that. It's pretty close to being symmetric. Skewed would be if one of the tails was a lot longer. Okay, so what we're going to talk about in this video is, let's say you have a symmetric distribution. We're going to see that there are two different notions of center. Remember, because we talked about the shape, there's the shape. The shape of the distribution are their outliers, what's the center and what's the spread. So we're going to see that for numerical variables and numerical distributions, that there are two different ways to think about the notion of center. And when we talked about the center, that also meant what was a typical value or what was a usual value. Okay. So the first one that we're going to talk about, the first meaning of center that we are going to discuss, is the center or typical value as the balance point of the distribution. And when you think of the center or typical value as the balance point of the distribution, we call this the mean. You probably have seen this before. The mean is also known as the arithmetic average. That's where you take all the numbers, add them together, and divide by how many numbers you have. The reason we're looking at this, the mean or the balance point as the center or typical value of the distribution, is because if you are symmetric, then the mean is actually literally in the center. Okay. So let me show you like what this looks like in StatCrunch. We're gonna go and look at some examples of this. So let me switch over to StatCrunch. Okay, here we go. So this is a data set that has colleges, the year, and how much the tuition is. So what we're gonna do is we're gonna go to graph. We're gonna go to histogram, and we're gonna look at the price for in-state on campus. So these are public universities. If you live in that state and you live on campus, how much do you expect to spend? And we're going to scroll down here a little, and you can see that there are these markers. We're going to select mean, because remember the mean is the balance point. So looking at this distribution, you can see that the mean is basically pretty close to being in the middle of the distribution. Let me look at one other one. Let's do price out of state. There, that one looks a little better. So we're going to do out of state. Out of state living on campus with the mean marker. Let's close that one. So you can see that the green line is the mean. If you hover over it, it says the mean is about $38,329. So in other words, typically the price of out of state tuition and living on campus was about $38,329. So if you are someone who's coming from out of state and you're going to live on campus, that's how much you would typically expect to pay. And what's nice about this is because it's a symmetric distribution, right? The high point is in the middle and the right tail is about the length of the left tail. The mean is right about in the middle, which is good. Now let's look at a different graph. So let's go to histogram. And what we're going to do is we're going to select for our variable total enrollment. So we're going to look at how many people are enrolled at these different universities. And we're going to put the mean marker. So you can see that this distribution is definitely not symmetric, right? The high point is this first, the mode is this first bin right here. The mode is not in the middle. The middle would be over here approximately. Right about there, right? That's the middle. So the the mode is definitely not in the middle. This is right skewed, right? The right tail is very long. And you can see that the mean is right over here at 6,168. So what this is saying is that if you literally got blocks that looked like this histogram, where would the balance point of those blocks be? Like if it was one structure, if you had all those blocks, here, I'll copy this and let me copy the picture and go back. So copy the image. Okay, so we're going to switch back to Microsoft OneNote. Oops. Paste. Come on, paste. There we go. Let me adjust this so it's not so gigantic. There we go. So if you made what's it called? Like this was a block, and like on here it was all connected on the bottom with there was a platform, and you put blocks like this. Where would you find is the balance point? Well, the balance point would be right here at the mean. That's what we mean by the mean, is the balance point. Okay. So contextually, it tells you several things. So let's type it over here. So context, what's the context? The mean is the balance point physically. And in that sense, it tells you the typical value. Right, so like in terms of total enrollment, typically it's about 6,000. Now you can see that there are schools that go up to 70,000 and 60,000, but typically most of them are over here in this bin with less than 10,000. So because of that, or sorry, less than, what is it, let's erase, less than 5,000. Like you could see the most common, the mode, the biggest bin, this one over here, has 0 to 5,000 students. But there are some universities that have like 60 and 70,000. So because of that, typically, that's where you get this little marker right here. It's about 6,000 is what's typical. If we go and look at the other one, the price of out of state, what's it called? Oops, it's not letting me copy it. 1 second. Okay, 1 second. Okay, there we go. I've got my. It took me a while to copy the image. So here, if you look at the price for out of state on campus living, it could cost you upwards of about $60,000, right? That's these bins around here. But it also could cost you less than $10,000, for instance, at a place like Ohlone. But typically, that's what we have the mean for, right here. This is where the balance point would be. It's around $39,000. Okay, so this idea of typical says, like, look, like, if it's symmetric, it's going to be close to the middle. If it's not symmetric, it's going to give you a sort of decent idea of what typically happens. Okay, so how do you calculate these numbers? How do you calculate the mean? You should do this by hand if you are dealing with a sample size of, I'd say, like 20 or less. So let's say your data only has information about, say, 20 or fewer subjects. You can actually do this by hand, and I'll show you how in a moment. So first, some notation. So let's say your variable is called x. And x is, I don't know, the age of people. If you want to say, okay, what is the mean or typical value for x, you write x with a bar. So this means mean of x. And actually, technically, it's the sample mean, because it's the average for the people you have. So how do you calculate the mean? So what you do is you take all your numbers and you add them together. So the way you write that down is with this Greek sigma in math. This means add up all your numbers. So xi means the different numbers. So it says add up all the different numbers. And then divide by how many numbers you had. So n is how many subjects in your sample. And this means add up all the ages of your subjects. Add ages of subjects, because remember I said we're going to look, the variable is x, their ages. So you take all the different ages, add them together, divide by how many people you had. So you can do this for small data. So as an example, let's say, I don't know, our sample is a group of Ohlone students, and you find out the ages are 17, 23, 31, 25, 22, 19, 18, 20. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8 students. So how do you find the average for this? Well, you first start by adding together all of these numbers. And then what are you going to have to divide by? How many numbers there were, of which there were 8. So let's add this together. If you add all the 10s, you get 10, 30, 60, 80, 100, 110, 120, 140. And then if you add all the single numbers together, 7 plus 3 is 10, plus 1 is 11, 16, 16 plus 2 is 18, 18 plus 9 is 18, plus 9 is 27, 27 plus 8 is 35. 140 plus 35 is 175, so you get 175 divided by 8. And actually, interesting enough, if I go equals 175 divided by 8, or if I do 175 divided by 8 equals 21.87. Let's do 21.9. So what does this mean? It means that the typical age for the people in this sample is 21.9. So typically someone's about 22 years old, even though the ages range from as low as 17 to as high as 31. Okay? So obviously this is not very fun to do if you have lots of data, because you have to add up all the numbers and then divide. So usually if you have lots of data, you use StatCrunch. So if you have lots of data, you should use StatCrunch. So let me quickly show you how to do that. So let's switch over to StatCrunch. Excellent. Okay, I'm back here. So let me close these. So let's say you wanted to know the mean of tuition and fees. Like typically in tuition and fees, how much would you spend? So you can go to stat, and I recommend you go to summary stats, columns, because each variable is a column. So what you do is you select tuition and fees, and then it's going to calculate a bunch of different statistics for you, one of which is the mean. So compute, and you can see that this is the summary statistic for tuition and fees. The mean is 18,738, you can see from here. So this is telling you, okay, if you look, typically what's the tuition and fees? About $18,000. N is the number of observations. So this data comes from 122 different colleges. So if you're looking at these 122 different colleges, typically what is the tuition and fees? $18,738 approximately. Cool. All right. So remember, the mean tells us what is typical. But how far from typical is usual? So the problem is that the mean is a single number that tells you, hey, if you need a single number that tells you what's typical, this is the single number. But like from this age example up here, the typical age of 22 You know, some people some people are not 22 and in fact are a lot older or a lot younger than 22. So now what we're wondering is like, hey, so if you know what's typical, how far from typical do people usually go? Like, you know, some people are obviously like this person who's 31 is a lot older than everyone else, but usually how close to typical are most people is the big question. And to answer this question, there's something called variation or spread. And in particular, we're going to learn about something called standard deviation. So just like how mean is a measure of center, standard deviation is a measure of spread. If you think back, we talked about shape, outliers, center, and spread. Mean is a measure of center. Standard deviation is a measure of spread. It tells you how spread out your data is. So standard deviation measures how far a typical observation is from the mean. So let's say you have your data. Say there's 100 students. You're like, look, these 70 students are typical students. So those typical students, they're not going to all have the typical age. They're going to be close to it, though. The question is how close. So the question is, how close are typical subjects from the typical value, i.e. the mean? Because the mean is, the typical value is one number, but not everyone's going to be exactly at that number, right? They're going to be a little away from it. Okay. And an interesting fact about standard deviation is about 68% of observations are one standard deviation from the mean. And we'll discuss this more later. So, first of all, let me just show you how the standard deviation is calculated and what the symbol is. So if you want to talk about standard deviation, you always use the symbol S. So S stands for standard deviation. How do you calculate the standard deviation? Well, what you're going to do is you're going to take each observation. So xi is your observation. And then from that observation, you're going to subtract the typical value. And then you're going to take that and you're going to square it. Now you do that for every single number. Every number minus the mean squared. And then you add all of those together. And then what do you do to that? Divide by the number of observations, and then take the square root. Now I imagine that some of you who don't like calculating things are like, holy crap, that is not cool. Luckily, StatCrunch is going to usually do this for us. So let me just take you back to StatCrunch. You can see that we have the number standard deviation right here. Okay, so what does that mean? It's telling you, okay, your typical university, it's not going to cost exactly $18,738. It might cost $12,000 more or $12,000. Well, $12,293 more, or maybe $12,293 less. Okay, so let's go back over here. So let me draw something. So your typical university had about $18,000 in fees. But the idea is standard deviation gives you some padding. You might cost up to $12,000 more, because that was the standard deviation, or you might cost $12,000 less. So 18,000 plus 12,000 is about 30,000. 18,000 minus 12,000 is about 6,000. So in other words, typically, a typical school will cost somewhere between $6,000 to $30,000. Not every school is going to have fees and tuition at that typical value of 18,000. They're going to deviate from that a little, and the standard deviation helps you figure that out.